Hello everyone, this is Puran. I'm HOD Physics, where we provide personalized attention to each and every student. So in this video, I'm going to discuss JEE Advanced 2023 Physics memory-based questions. I've received these questions from my students, and most of these questions directly came from PracBee's lecture notes. And the difficulty level for this year's JEE is from easy to moderate. So without wasting much time, let's start with the session. So the very first question came from gravitation. Now it is directly formula based. So let me read the question. The ratio of the gravity field due to the earth at the height HP and HQ from the earth's surface is 36:25. If HP is R by 2, then the value of HQ will be. So we know that the gravitational field is given by this formula, that is capital G mass of the earth divided by the square of the distance from the center of the earth. Now the height, so height, where height is basically from the surface, so we can say this will be gm upon r plus h square. So we can write it like this. Now so the field at P will be gm upon r plus hp square. Similarly, field at Q will be gm upon r plus hq square. Now if you take the ratio of these two, so we have given 36:25, so it will be r plus hp square, and in the numerator will be having r plus hq square. Now from this equation we can very easily calculate the ratio of the height, and we have to find the value of HQ. So let us simplify. Let's take the square root on both sides. So this will become 6/5, and we have R plus HQ upon R plus HP, and we have given HP as R by 2. So it will be 6/5 times R plus R by 2 will be 3R by 2. So this will be 3, and then we can say R plus HQ. So HQ comes out to be 9/5 minus 1 times R, which will be 4/5 R. So we can see the option C is the right answer. So it is a very easy question. So I say such type of question basically it qualifies for JEE mains, not for advanced. So it is very easy. So let us see the next question. So two small particles of mass 20 grams and 30 grams are connected with a rigid massless rod of length 10 centimeter. The center of mass of the system is suspended by a steel wire of torsional spring constant 1.2 into 10 raised to minus 8 Newton meter per radian. If the system slightly rotated in its plane and the angular frequency of its oscillation in radians per second is given by n times 10 raised to minus 3, then write the value of the n. So again, it's a directly formula based question. So what we have given, so we have given, let us say this is the ceiling, and we have a massless rod, and at the end of this massless rod we have two particles. Say one particle is having a mass of 20 gram and the other particle is having a mass of 30 grams, and the point of suspension basically passes through the center of mass of this system, and the center of mass will be closer to the 30 gram particle. So we can say this system can rotate about this particular axis. So we know the formula, the time period for a torsional pendulum, you can say it will be 2 pi root I by C, where I is the moment of inertia about the axis of rotation and C is the torsional constant. So what is I? So if we have to find the moment of inertia about an axis passing through the center of mass, what we can do? We can find the reduced mass, which will be given by m1 m2 upon m1 plus m2. So in this case it will be 20 times 30 divided by 50. So we are getting 12 grams, right? Now that is the reduced mass, and the moment of inertia about an axis passing through the center of mass will be, it will be mr square. So m, or you can say mu r square, where r is the distance between the two masses. So mu will be 12 upon 1000, and r in this case is given to us as 10 centimeters, so it will be 0.1 square. So we are getting 12 into 10 raised to power minus 4 kilogram meter square. So that is the moment of inertia about the axis of rotation. So let us plug in the value in the formula. So we have 2 pi root moment of inertia is 12 into 10 raised to power minus 4, but in this case we have to calculate the angular frequency. So angular frequency will be given by root of c by I. So let us find this value. So C is 1.2 into 10 raised to power minus 8 divided by the moment of inertia, which is 12 into 10 raised to power minus 4. Oh, sorry. So we have to, so this is 12, so there has to be 1000 in the denominator, so it will be 12 into 10 raised to power minus 5. So if we simplify this, we will get 0.1 into 10 raised to power minus 3 root of that, which is nothing but 10 raised to power minus 2. And omega is given to us as n times 10 raised to power minus 3, so n comes out to be 10. Okay, so it is very easy question, direct based on the formula. Now let us see the next question. A hydrogen-like atom of atomic number Z transits from n equals to 4 to n equals to 3. The photon emitted from its transition is incident on the metal surface of the threshold wavelength 310 nanometer. If the maximum kinetic energy of the emitted electron is 1.95 electron volt, then find the value of Z. Now, in this, this is basically, you can say, from Einstein's photoelectric effect. So here we have given threshold wavelength. So from threshold wavelength we can find the work function of the metal. So work function will be given by, in electron will be given by 1240 divided by the wavelength in nanometer, which is 310. So if you simplify this, it comes out to be 4 electron volts. Now we know what is the work function. Now we have given an hydrogen-like atom and it has an atomic number Z, transits from 4 to 3. So this is, say, n equals to 4, and let us say this is n equals to 3. So when the electron transits from n equals to 4 to n equals to 3, it emits a photon. Now let us find the energy of this photon. So the energy of this photon will be given by 13.6 times Z square times 1 by 9 minus 1 by 16, right? We all know this formula. So this is the energy of photon. And by Einstein's photoelectric equation, we know that the energy of photon, which is incident on the metal surface, will be nothing but the work function time plus the maximum kinetic energy of the electron, photoelectron. So phi we have calculated, it is 4, and K max we have given, it is 1.95. So, and this is 13.6 Z square, and that will be 7 divided by 9 into 16. Now from this, the right hand side will be 5.95, and from this equation we can very easily calculate Z. So if you simplify this, Z square comes out to be 9 and Z will be nothing but 3. So again, it is a very standard problem. So in this question we have given a circuit, right? So basically it is from current, electricity, and in the latter part we have to use capacitors. So in the circuit shown in the figure, the capacitor C is initially uncharged and the key K is initially open. In this condition, a current is 1 ampere flows through the resistor, 1 ohms resistor, and the key is closed at time t equal to t naught. Choose the correct option. And we have given e raised to power minus 1 is 0.36, and options are R is 3 ohms, before t equals to t naught I1 is 2 ampere, at t equals to t naught plus 7.2 microseconds. Current in the circuit is capacitor is 0.6 ampere. At t tends to infinity, basically steady state charge on the capacitor is 12 microfarad. Okay, so initially the key is not closed, so let me redraw the diagram. So we have these batteries in parallel. So 15 volt resistance is R, and then we have 5 volt battery and its internal resistance is 1 ohm, and the current in this branch is 1 ampere. And we have another resistor which is in parallel with these two batteries. Now we have given branch in the middle battery, let us say in the middle branch. We need so what we can do, we can consider these two branches. Let us say I am considering an EMF 0, right? If I consider here as a EMF 0, we can say now we have two batteries which are in parallel. So what is the equivalent for these two batteries? It will be 15 by R plus 0 by 3 divided by 1 by R plus 1 by 3. So let us simplify this. So 15 by R times 3R upon 3 plus R. Now this R will get cancelled out, so this becomes 45 upon 3 plus R. So if I redraw this diagram, it will look like this. So we have a battery whose EMF is 45 by 3 plus R, and its equivalent resistance will be nothing but 3R by R plus 3. and it is connected in series with a battery in a 5-volt battery, and the current in this battery is given as 1 ampere. Now just a straightforward question, we can apply KVL, and so if we apply KVL, we will get 45 upon 3 plus R minus 5 is equals to I times the total resistance of the circuit, which will be 1 plus 3R upon R plus 3. So let us simplify this. In the left hand side it becomes 45 minus 15 minus 5R. On the right hand side we will get R plus 3 plus 3R. So let us combine the like terms. So we will get 9R on one side and 27 on the other side. So if we simplify this, we will get it is 3 ohms. So we can say option A is correct. Now in option B, before T is equals to T naught, I1 is 2 ampere. Now we have to find the current through 3 ohms resistor. So what we can do, we can consider these two batteries in parallel, right? And then we can find the current I1. So let us do that. Now we know what is the resistance R. So let me redraw the diagram. So we have 15-volt battery and the resistance is 3 ohms, and this battery is having a EMF 5 volt and the resistance is 1 ohm, and it is connected with 3 ohms resistor, and we have to find this current I1. Okay, now these two batteries are in parallel, so we can say E equivalent will be 15 by 3 plus 5 by 1 divided by 1 by 3 plus 1 by 1, which will be nothing but 10 upon 4 multiplied with 3. So that will be 7.5 volts, and R equivalent will be nothing but 3 upon 4. So this circuit will look like this. So we have a battery of EMF 7.5 volt and the internal resistance is 3 by 4, which is connected in series with a resistor of 3 ohms. So the current I1 will be given by 7.5 upon the total resistance of the circuit, which will be 3 by 4 plus 3. So this will be 7.5 upon 12 plus 3 will be 15 times 4. So this will be 3 and this will be 1.5, so this will be 0.5. So we are getting 2 amperes. So let us see the option. Yes, so it is given as 2 amperes. Now in option C, at t equals to t naught plus 72 microseconds, current in the capacitor is 0.6 ampere. Now what we can do, we can have a charging capacitor circuit, right? RC circuit. Let us form that particular circuit. So we have 3 batteries in parallel. So if these 3 batteries are in parallel, so we can redraw the diagram. So it will look like this: R equivalent, E equivalent, which is connected with the capacitor having capacitance 2 microfarad and the resistor is 3 ohms. So let us find the equivalent EMF of this. So 15 by 3 plus 5 by 1 plus 0 by 3 divided by 1 by 3 plus 1 by 1 plus 1 by 3. So this will become 10 upon, so this will be 6 by 3, right? 5 by 3, right? So this will become 2 times 3, which is 6 volts, and the R equivalent will be 3 by 5 ohms. So this circuit, so let me put the values. So we have 6 volt battery and the internal resistance is 3 by 5, which is connected with this resistor, with this capacitor of 2 microfarad capacitance, and here we have a resistance 3 ohms. So the R equivalent in this case, the total resistance of this charging circuit is 3 by 5 plus 3, which will be 18 by 5. So the time constant for this circuit will be R equivalent times the C. R equivalent will be, is given as 80. It is 18 by 5 and the capacitance is 2 microfarad. So this comes out to be 36 by 5 microseconds. Now we have to find the current in the capacitor in when the time is 7.2 microsecond. So we know that in a charging circuit the current decreases. So current will be given by the maximum current, which will be 6 E by R equivalent, which is 18 by 5 e raised to power minus t by tau. Now t here we have given 7.2 microsecond, and our time constant we have calculated is again 7.2 microsecond. So this is 3, so 5 by 3 multiplied with e raised to power minus 1 is 0.36, so this comes out to be 0.12, and this will be 6 ampere. So it means option C is also correct. Now when time tends to infinity, it means the steady state, the charge on the capacitor is 12 microcoulomb. So charge is nothing but it will be fully charged, so when we can say it will be CV, and V will be the EMF, which will be 6 volts, and the capacitance is 2, so this will be 12 microcoulomb. So all the options in this question are correct. So I would rate this question from moderate to difficult, right? So let us see the next question. A person of height 1.6 meter is walking away from the lamp post of height 4 meter along the straight line on a horizontal ground. The lamp post and the person are always vertical. If the speed of the person is 60 centimeters per second, then find the speed of the tip of the shadow with respect to the person in centimeters per second. Okay, the similar question was asked in advance, say a way back. So let us see the diagram of this question. So we have given a person, and here we have given a lamp post, and this is the ground, and the shadow of this person is being formed like this. So this is the tip of the shadow, and we have to find the speed of the tip of the shadow with respect to the person. Okay, so let us find the speed of the tip of the shadow with respect to ground first, and then we can use relative motion and we can find the speed of the tip of the shadow with respect to the person. So let us say this distance is x, and the distance of the person from the lamp post is y. So I can say this distance will be x minus y, and the height of the lamp post is given as 4 meters, and the height of the person is given as 1.6 meters. So first of all, let us apply similar triangles. We can see two right angle triangle here. So we can say x minus y upon x will be 1.6 upon 4. So from this we have a relation in x and y. So we can say this will be 0.4. So we have y equals to x minus 0.4x, which is 0.6x. Now if you differentiate this equation, we will get dy by dx, dy by dt, and dx by dt, and dy by dt is nothing but the rate of change of the position or the distance y with respect to time. So it will give us the speed of the person. So dy by dt is equals to 0.6 times dx by dt. Now dy by dt is the speed of the person, dx by dt is the speed of the the tip of the shadow in ground frame. So this is given as 60 centimeters per second, so divided by 0.6, so dx by dt, so this comes out to be, you can say, 100 centimeters per second. Now this is the speed of the tip of the shadow. So with respect to the person, both are moving in the same direction, let us say. So we can say it will be 100 minus 60, which comes out to be 40 centimeters per second. Again, very easy question. Now let's move to the next question. Find the value of alpha, beta and gamma in this equation, where y is given as y is Young's modulus, c is the speed of light, h is the Planck's constant, g is the gravitational constant. Again, a very basic question. So let us solve this. So let us find the dimensional formula for all these physical quantities. For Young's modulus, it is having a dimension of a stress, so it will be force upon area, so basically pressure. So force is given by m raised to power 1, l raised to power 1, t raised to power minus 2, and divided by area, which is L square. So this will be m raised to power 1, L raised to power minus 1, T raised to power minus 2. Similarly, the dimensional formula for speed will be L T raised to power minus 1, and dimensional formula for Planck's constant. We can find this by using E equals to h nu. So energy will be m raised to power 1, L raised to power 2, T raised to power minus 2, and divided by the frequency, which is T raised to power minus 1. So this will become m raised to power 1, L raised to power 2, T raised to power minus 1. And for G, it will be force times the square distance of the square divided by square of the mass. So that will be m raised to power 1, L raised to power 1, T raised to power minus 2 times L square divided by m square. So this will be m raised to power minus 1, L raised to power 3, T raised to power minus 2. Right? Now, so we have to form a relation. So in Young's modulus, if you see, the mass has a power 1, right? M has a power 1. Now we can see there is no mass in speed, right? There is no mass in speed, and we are getting m raised to power 1 in h and m raised to power minus 1 in g, right? So it means the power of h is beta, so we can say beta, and power of g is gamma, so minus gamma, right? It has to be, you can say 1, right? It has to be 1. Okay, so if it is 1, so what we can do, let us check the options. So in the first option, beta is minus 1, so minus 1, and gamma is minus 2, so plus 2, so we are getting plus 1. If you check for other options, you will not get plus 1, so we can say option A is the right answer. Again, a very basic question. Okay, so next is a question from thermodynamics. So 1 mole of an ideal gas expands adiabatically from the initial state Ta V0 to a final state Tf 5 V0, right? So initial temperature is Ta, final temperature is Tf, and there is an expansion and volume is increasing from V0 to 5 V0. Another mole of the same gas expands isothermally from the different initial state Tb, V0 to a same final state Tf 5 V0, and the ratio of the specific heats of the constant pressure and constant volume of this ideal gas is lambda. We have to find the ratio of Ta and Tb, right? So the ratio of these two. So before solving this question, let us draw the indicator diagram. So on the y-axis I am showing the temperature, on the x-axis I am showing volume. So the volume initially is V0, so we can say the initial state will start from this particular line, and the final state will be on this particular line, which is 5 V0. Okay, so one of the process is isothermal. So let us say this is Tb, and we are expanding gas isothermally, right? So that is the graph for that. And we know that in adiabatic process, as the volume increases, temperature has to decrease. So it means Ta has to be somewhere here. So it will be non-linear graph, and the final state is same in both the cases. So here temperature is Ta, and here temperature will be Tb only, right? Because this process is an isothermal process. So Tf is nothing but Tb. Now for this particular process, which is an adiabatic process, if we want to find the relation between Ta and Tb, we can use the property of adiabatic process, in which Tb raised to power lambda minus 1 is constant, right? So we can use this relation. So initial temperature at this particular point, let us this point is P and this point is Q. At P the temperature is Ta and the volume is V0. So this will be lambda minus 1, and then the temperature at Q is Tb and the volume is 5 V0 raised to power lambda minus 1. Now from here we can very easily calculate the ratio of temperatures, right? So it will be 5 raised to power lambda minus 1. So it should be lambda minus 1, right? Option B is the right answer. Okay, so again, not a very difficult question, so I will rate this question from easy to moderate. So next, for a thin convex lens object is placed in front. Okay, so for a thin convex lens, object is placed in front of the lens, and the distance of the object from the lens is 10 plus minus 0.1 centimeter, and the distance of the real image formed from the lens is 20 plus minus 0.2 centimeter. The error in determination of focal length of the lens is n%, and the value of n is. Now the same question for the same concept was asked in the previous year's papers, so we have to use the same concept. So basically we should know what is the lens formula, and we should know how we can find the error by using the formula. So here we have given you, so let me draw the diagram. So we have a convex lens, and there is an object which is placed at a distance 10 centimeter, and image is being formed, real image is being formed at a distance of 20 centimeter. So we know u, which is minus 10 centimeter, v is plus 20 centimeter. So from here we can find the actual value of the focal length. Focal length will be, so 1 by f will be 1 by v minus 1 by u. So 1 by 20 minus of minus 10, so this comes out to be, so 20 will be LCM, 1 plus 2, so this will be 3 by 20. So focal length, value of the focal length is 20 by 3 centimeter. Now how we can find the error in the measurement? So for that we know the formula. So if I differentiate the lens formula, right, so I will get this relation, delta f by f square equals to delta u by u square plus delta v by v square. Now if I take one of the f on the other side, I will get this. If I multiply this with 100, I will get percentage error in focal length. Now the error in u is given as 0.1 and error in v is given as 0.2. So let us put the values. So 0.1 and u is 10 minus 10, so square of that will be 100. Delta v is the error in the distance of the image, which is 0.2 upon 400 square, sorry 400 multiplied with 100, and the focal length is 20 by 3. So let us simplify this. So we're getting 0.6 by 4 times 20 by 3, so this will be 0.25, so it comes out to be 1, so we can say it will be 1%. So the option C is the right answer. Let's see the next question. Liquid is rising at a rate of 250 cubic centimeter per second in a container. Value of the capacitance of the container after 10 seconds. Right, so let us see. Now we have a container and liquid is being filled up in this container. So let us find how much amount of the water which will get entered in this container. So let us find the amount of water. So that will be 250, or the liquid, so not water. So we have a liquid which has a dielectric constant 3. So the amount of water which enter in 10 seconds will be 250 times 10. So this will be 2500 cubic centimeter. Okay, so now if I want to find the height up to which this water rise, so let us say this height is x. So we can say this volume will be 5 into 50 into x. Now from here x comes out to be how much? 10 centimeters. Okay, so now we know what is x, and if I want to find the capacitance, so I'm considering in this case, let us say the battery is connected like this, right? So I'm finding capacitance of, between these two plates. So for this you can say we have two capacitors. One is having a dielectric constant K, other will be having vacuum, right? So let us say this has a capacitance C1 and this one is having a capacitance C2. Now C1 will be K times, which is the dielectric constant K times epsilon naught, the area of the plate. So this area, which will be 50 times the x, which is 10. So 50 times, you can say 0.1 in meters, divided by the width between these two plates, so it will be 5 centimeter. So let us simplify this. So this comes out to be 10, so we can say it is 3 epsilon naught. Now for C2, it will be epsilon naught times the area of this plate, which will be x is 10, so this will be 40. So this is 40 centimeter, 40 times 50. So 40 times 50, you can say 0.5 divided by the width. So that is 5. So this comes out to be 8. So 8 5 is 40. So it will be 4 epsilon naught. Now let us find the equivalent capacitance. So C equivalent will be C1 plus C2. So that will be 7 epsilon naught. Now epsilon naught is given as 9 into 10 raised to power minus 12, so which will be 63 into 10 raised to power minus 12, right? So that should be the answer, 63 into 10 raised to power minus 12. So option D is the right answer. Again, very basic question. Now let us see the next question. A bar of mass 1 kg and length 0.2 meters is lying on a horizontal frictionless surface. One end of the bar is pivoted so that the bar is free to rotate in a horizontal plane. A small particle of mass 0.1 kilogram is moving on the same horizontal surface with a speed 5 meters per second on its path, which is perpendicular to the bar. It hits the bar at the distance L by 2 from the pivot end and returns back on the same path with the speed v. After this elastic collision, the bar rotates with an angular velocity omega. Which of the following statements is correct? So let me draw the diagram. So basically it is a typical question of collision with rotation, right? So we have given a rod which is having a mass 1 kg and its length is 0.2 meter. Now it is pivoted at this particular end, so it can rotate freely about this particular end. Now there is a particle which is coming like this, and this particle is hitting this rod at its center of mass. Now this particle is having a mass of 0.1 kilograms and its initial speed is given as 5 meters per second. Now what would happen? So when this particle hit this rod, it will impart an impulse, right? It will apply an impulse. Due to that impulse, or the rod will exert an impulse on the particle, due to which the momentum of the particle will change. So let us say the impulse that is being exerted on the particle, its direction would be this, right? In the downward direction, let us say in this direction, this is the impulse. Now initial momentum will be, so we can say initial momentum will be mass times the velocity, which is opposite to the impulse, so it will be minus 5. So this will be minus 0.5 kilogram meter per second, and the momentum after collision will be, let us say the particle acquire a velocity, say v, in this particular direction, so that will be 0.1 times minus v, right? So the impulse will be the change in momentum. So this comes out to be how much? So 0.1 will be common, so final, so minus v minus of minus 5, right? So this comes out to be how much? 0.15 minus v. Now this is the impulse. Now due to this impulse, there will be an angular impulse on the rod, due to which this rod will rotate about this axis, and let us say the omega acquired, or angular velocity acquired by this rod after collision, is omega. So we can say the angular impulse will be given by j times the perpendicular distance from the axis of rotation. So this distance is nothing but 0.1 meter. So we can say j times 0.1 meter will be equals to the change in angular momentum. So that will be I omega. So in the moment of inertia of a rod about an axis passing through the end is ml square by 3. M is 1, and the rod length is 0.2, ml square by 3. So from here we have omega as a function of v. So let us substitute the value of j in this equation. So we will get 0.5 minus 0.1 times v times 0.1. So this will be 0.04 by 3 omega. Okay, so here we have a relation. So let me just remove these decimals. So we are getting 5 minus v times 3 equals to 4 omega. So we have a relation, right? So what else we can do in this case? Since it's an elastic collision, we can say the velocity of separation should be equal to velocity of approach along the line of impact. So velocity of separation should be equal to velocity of approach along the line of impact. So what is the velocity of separation? It will be, what is the velocity of this particular point after collision? This velocity will be omega times the distance, that will be 0.1. Okay, so velocity of separation will be omega times 0.1 minus v, and the velocity of approach is nothing but 5. So from here we can say v is nothing but 0.1 omega minus 5. So let us substitute this value in this equation. So we will get 3 times 5 minus 0.1 omega minus 5 equals to 4 omega. Now from this equation we can find the value of omega. So let us simplify this. So 10 minus 0.1 omega multiplied with 3 equals to 4 omega. So this comes out to be 30 minus 0.3 omega equals to 4 omega. So 30 equals to 4.3 omega. So if we simplify this, so 30 divided by 4.3, it comes out to be 6.98 radian per second. So let us check the question, options. 6.98. So we can see option D is the right answer. So now we know omega, we can find the speed v. Okay, let's see the next question. So we have given a thin conducting rod Mn of mass 20 grams and length 25 centimeter. So this is the rod. This rod has a mass 20 grams. So M is given as 0.02 kilograms and the length is 0.25 meter and the resistance of this rod is 10 ohms. And it is held on a frictionless, long, perfectly conducting vertical rail as shown in the figure. There is a uniform magnetic field of 4 Tesla directed perpendicular to the plane of the rod rail system. Now the rod is released from rest at t equals to 0 and it moves down along the rails assuming air drag is negligible. Now we have to match the values in these two lists. Now this is the question based on electromagnetic induction. In such cases, when there is a rod which is moving and we have to find some physical quantities at a particular time, so what we are going to do, we'll consider, let us say the velocity of the rod is v at time t, right? So v at time t. So when the velocity is v, we can say the circuit will look like this. So there will be an EMF induced, that is nothing but the BLV. So we know this formula BLV. So BLV is nothing but 4 multiplied with L is 0.25 times V. So this will get cancelled out. So we can say EMF induced will be nothing but V. Right? So this EMF induced, due to this, since we have a closed loop and there is a resistance, right? It has some resistance also. So we have closed loop. So due to this, there will be an induced current. And due to this induced current, there will be a force on this rod by the magnetic field. So if I draw the free body diagram of the rod, so there is a current in this direction. It is having there is a force of gravitation in the downward direction, which will be mg. M is 10. M is 0.02. mg is 10. So we can say it will be 0.2 Newton in the downward direction, and there will be a force in the upward direction, which will be ILB. I is the current, and the current will be E by the resistance. So that will be V by R, and R in this case is 10. So current will be V by 10. So we can say the magnetic force will be ILB, and L into B is nothing but 1. So that will be V by 10. So if I apply Newton's second law, so there is a net force in the downward direction. This is nothing but V by 10. So 0.2 minus V by 10 should be equals to mass times the acceleration. And mass of the rod is 0.02 and acceleration is A. So now let us multiply throughout by 10. So we are getting 2 minus V equals to 0.2 A. So it will be 10 minus 5V equals to A. Now we have a relation in velocity and acceleration, and we have to calculate different quantities. For example, we have to calculate EMF induced, right? For that we have to find V, right? So let us find V as a function of time. So I can write A as dV by dt. So we have a differential equation in V and time. So it will be dV by 10 minus 5V is equals to dt. So if I integrate this, now initial velocity is 0, from 0 to some general velocity V, and time is from 0 to t. So left hand side will be nothing but the natural log of 10 minus 5V, and the limit will be from 0 to V. On the right hand side we're getting t. So this can be written as natural log 10 minus 5V divided by 10 equals to t. Obviously, okay, and there has to be, we have to divide by the coefficient of the V, that will be minus 5. So there will be minus 5 also in the denominator. So we are getting 1 minus V by 2 equals to e raised to power minus 5t. So we can say velocity 1 minus V by 2 equals to e raised to power minus 5t. So V is equals to 2 times 1 minus e raised to power minus 5t. Okay, so now we have velocity as a function of time. So let us see, say for p, okay, so okay, let us first check s, right, the magnitude of the terminal velocity of the rod. So if I draw the graph of this for v, and this is time, you can clearly see that the graph will look like this, and after some time the velocity of the rod will become constant, and this velocity will be nothing but 2 meters per second. So we can say for s it will be 5, right? For s it will be 5. So you can see for s 5 comes only in the option C, so option C is the right answer. Similarly, we can find the other physical quantities because we have velocity as a function of time. I hope it is clear. So let us move to the next question. Again, this question is quite easy. A particle of mass m is moving such that its velocity at a point x comma y is given by v equals to alpha y I cap and alpha 2x times j cap. So this is given to us, where alpha is a non-zero constant. What is the resultant force acting on the particle? So for resultant force, we should know what is the acceleration in the x direction and acceleration in the y direction. So we can, from this equation, we can clearly see that velocity in the x direction will be alpha times y, and velocity in the y direction will be alpha times 2x, right? And we know, and we have to find acceleration. So for that, I can say, if I differentiate this, so dvx by dt is the acceleration in the x direction, which will be alpha times dy by dt, which is nothing but the velocity in the y direction. So we can say acceleration in the x direction will be alpha times 2x. Similarly, acceleration in the y direction will be alpha times 2 times dx by dt, and dx by dt is nothing but velocity in the x direction, alpha times 2 times alpha times y. So we can say acceleration in the x direction will be 2 times alpha square y. Now the net acceleration, or you can say the acceleration in vector form, will be ax I cap plus ay j cap. So that will be 2 alpha square x I cap plus 2 alpha square y j cap. So the force which is acting on the particle will be mass times acceleration. So this will be 2 alpha square m x I cap plus y j cap. Again, direct formula based question, so we can, it is quite easy. Now let us see the question 13th. A closed container constrained a homogeneous mixture is made of 2 moles of ideal gas, ideal monatomic gas. So we have given 2 moles of monatomic gas, right? So, and we have given 1 mole of diatomic gas. Here gamma is the ratio of the specific heat at constant pressure and constant volume of the ideal gas. The gas mixture does a work of 62 joules when heated at constant pressure. Now the pressure is constant. Now change in its internal energy. So we have to find change in internal energy. Again, a quite standard question. First of all, we have to find the ratio of molar heat capacity for this mixture of the gas, right? So gamma for mixture is given by N1 Cp1 plus N2 Cp2 divided by N1 Cv1 plus N2 Cv2. Now Cp1 is the molar heat capacity at a constant pressure for the monatomic gas, and Cp2 is the molar heat capacity at constant pressure for a diatomic gas. Now Cp1 for a monatomic gas, it will be 5 by 2R, and Cp2, sorry, so for Cp2 for a diatomic gas, it will be 7 by 2R, and Cv1 will be 3 by 2R, and Cv2 will be 5 by 2R. So let us put in the values. So N1 is 2, N2 is 1, so 2 times 5R by 2 plus 1 times 7R by 2 divided by 2 times 3R by 2 plus 1 time 5R by 2. So let us simplify this. We are getting 10 plus 7 upon 6 plus 5, so this comes out to be 17 by 11. So gamma is 17 by 11, and we have to find the change in internal energy, and we have given constant pressure process. So we know that delta U is F by 2 nr delta T, and F by 2 can be written as 1 upon gamma minus 1. So 1 upon gamma minus 1 times nr delta T, and we know that in isobaric process work done is given by nr delta T. So work done value is 66, and gamma we have calculated 17 by 11. So from here we can say it will be 66 times 11 divided by 6, so that comes out to be 121 joules. So delta U in this process, in this case, will be 121 joules. Again, a very basic question. Yes. Now the next question is from mechanics, or you can say here we have multiple concepts. Here we can use conservation of mechanical energy, and then there will be a collision concept, projectile concept. So multiple concepts are there in the same question. A ball is released on a smooth inclined plane as shown. It strikes the ground, and the coefficient of restitution is 1 by root 3. Choose the correct option. So first of all, this V, option A V, it tells us the velocity just before leaving this track is root 2gh times I cap, or you can say x cap, which x cap is the unit vector in the direction of x-axis. So in order to check for option A, what we can do, we can use conservation of mechanical energy. So if we do conservation of mechanical energy between this position and this position, we can say there is a decrease in the gravitational potential energy and increase in the kinetic energy. So you can say loss in gravitational potential energy will be gain in kinetic energy. So loss will be mgh, and the gain will be half m, you can say v naught square. So from here v naught will be root of 2gh, and the direction is in the positive x direction, so we can say in vector form it will be root of 2gh times I cap or x cap. So option A is correct. Now the next part is at what angle this ball will strike the ground. Okay, so at this particular point, at what angle it will strike the ground. So for that we need to calculate the velocities in the x as well as in the y direction just before collision. So let us say Vx will not change because before collision there is no force acting in the horizontal direction, right? Vx will remain same, so we can say Vx is nothing but root 2gh, and Vy we can calculate by using kinematics equation, right, in the vertical direction. So we can say in vertical direction initial value in the y direction, initial value in the y direction is 0, and the final value is Vy, let us say, and the acceleration is, so sorry, the vertical direction is z-axis, so I can say it will be z, not y. I am writing it as z. So acceleration in the z direction will be minus g. So let us apply, and the displacement in the y direction, so displacement in the z direction will be 3h, or you can say minus 3h, let us say. So we can say vz square equals to uz square plus 2az times displacement in the z direction. So vz we have to calculate, uz is 0, this is z, and minus 2 times acceleration is g, and this will be minus 3h. So we can say velocity in the z direction will be root of 6gh. So now we know velocity in the z direction, so let me just show the vectors. So this is velocity in the x direction, and this is the velocity in the z direction. So the resultant velocity will be along the diagonal of this rectangle, and this angle is theta, so they want this angle theta, right? So tan theta will be vz upon vx. Vz is root 6gh and vx is root 2gh, so it is nothing but root 3, so we can say theta is 60 degree. So option B is also correct. Then Option C, it says velocity is root 2gh x I cap minus k cap, right? I cap minus k cap. So, but we know that velocity just before hitting the ground is root 2gh I cap minus root 6gh k cap. So option C is incorrect. And then we have to find the ratio of d and h. So for that, what we can do, so d is the range, right? From this point, say this point is A and this point is B, the range is d. So the time taken by the particle from A to B will be root 2h by g. So we can say time from A to B is root of 2h. H in this case will be 3h basically, right? So this will become 3h by g. So this is nothing but root of 6h by g. So we know the time from A to B, and the displacement is d. So we can say velocity in the x direction, which is v0, which is root 2gh, multiplied with the time, root of 6h by g. So from here we can find the relation between d and h. Now this g will get cancelled out, and we are getting, it will be 2 times root 3 times h. So d by h will be 2 times root 3. So we can see option D is correct. So here I conclude this video. So I hope it would be helpful for you, and for more such videos, subscribe our channel. And if you want to have a one-on-one session with me, the link for that is given in the description box. So I hope it will be helpful. Thank you.